Okay, so implicit differentiation. So yesterday we sort of were skimming the surface of implicit differentiation when we were talking about how you're taking the derivative with respect to x, but you could have other variables. You know what I mean? We did dA by dx and dB by x, that kind of stuff. So that, if you remember that from yesterday, that's going to be helpful. First of all, we've never used this terminology before, so we have to understand what these words mean. So I'm going to write down a few examples. Oh, thank you. Whoops. Okay, so there's 3 examples of explicitly stated curves and 3 examples of implicitly stated curves. So who notices the pattern? What's the pattern? What's happening here? What makes something explicit versus implicit? Zara? Not. Okay, these ones are equal to a value. Yeah, that's an interesting observation. They all have 2 variables. But you're on the right track. Zara, let me give you another one here. That would be fine as well. Yes, sir. Okay, you're on the right track. Zara? Is it because there's no constant in the equation? Yeah, this is usually fairly simple.
Is it that the implicit has 2 types of variables, or is it the explicit only one?
Kind of. I mean, they both have 2, but these ones are solved for y. They all say y equals. That's what makes them explicit. So they're in a form where they're ready to sub in for x and solve for y kind of thing. Whereas the implicit ones have x and y on the same side. Okay? That's all we mean by implicit. It's not solved for, and it doesn't have to be x and y's, obviously. It could be any variables. Solved for a variable. Okay? Now, just because a curve is stated implicitly doesn't make it an implicit curve. It's just a curve that's stated implicitly. So the examples here are, I could do this, I'll leave it in green, y equals 5 minus x. Same, what kind of a relation is this? X plus y equals 5, it's stated implicitly, but what kind of relation? It's linear. This is a line. Is everybody okay today? What kind of polynomial is it? It's a polynomial. It's a linear polynomial. And relations you could have a rational relation, or you could have all different kinds of relations, right? Relation between x and y. So this is linear, whether you write it this way or this way. Doesn't matter how you write it. It's the same line. This is a line stated implicitly. This is the line stated explicitly. Could I do that? Does anybody know what kind of relation this is? It is a circle. Very good. X squared plus y squared equals 25 gives you a circle. If I wanted to try to state this explicitly, what would I do? Well, I would do y squared equals 25 minus x squared. And then do y equals, when you take the square root of something, plus minus. And this looks like a square root function, but because of the x squared under the radical, it's not. And if I just did, in fact, that's for later. I hope this is on. If I just did the square root of 25 minus x squared, I would get a half circle. So this expression works, but having a plus minus in it is a bit weird, right? So it's almost like you'd have to graph two different functions to make up a circle, which is not a function, but the half circles would be functions. So anyway, this is a bit weird, but I suppose it's the explicit statement of a circle, y equals plus or minus the square root of that. But you can't take the derivative of plus or minus of something. I mean, you'd have to do it in two steps, right? So so that's the definition of implicit. It means you got x and y's muddled up together, basically. Is that okay? Now, this is what we talked about yesterday, and we've been taking, I said this I think yesterday, but we've been taking for granted that whenever we take the derivative, we've been taking the derivative, what we say is with respect to x. But you could take the derivative with respect to anything. You could take the derivative with respect to y. Okay? But generally, we usually take the derivative with respect to x. So if my curve is y equals x, then dy, I'm going to do x squared actually, dy by dx is 2x. But what if I did x equals y squared? Then it would be, I could do dx by dy equals 2y. Like I could take the derivative with respect to y. That's not what we're doing, but you could. And what we talked about yesterday was dy by dx is not just a notation. It's a thing. Right? Because we did this. Y equals x squared. What if I move the y over? 0 equals negative y plus x squared. And I wanted to take the derivative. It'd be 0 equals negative dy by dx plus 2x. Right? dy by dx is not just a notation. It's not just a different way of writing y prime or a different way of just writing y equals. It's actually a thing. Okay? So that's just understanding what the word implicit means. You don't really need it. You can get it after if you want. And we talked about yesterday how, technically speaking, the derivative of x is dx by dx, which is 1. So yes, the derivative of x is 1, but it's 1 because it's dx by dx. So what's the derivative of x squared? 2x. And if you're trying to write down what I write down, I'm leaving a little space there. So what would be the derivative of y squared? Well, hold on. I want to remind you of something. What would be the derivative of this? 2 g at x times g prime of x. What do we call that? Chain rule or power of a function rule is what we called it originally, right? Good. So what's the derivative of y squared? Guess. Go ahead and guess.
So 2 what?
So 2y, but what's the derivative of what's inside?
Y prime?
Except we can't use that notation. dy by dx. See, we've been skipping that part the whole time because dx by dx is 1, so we don't think of it that way. We don't write it that way. We skip it. It would be hard to open up derivatives and try to explain this from the beginning. You've got to do it for a week or so and get some skills before you can even talk about this. But it's actually like power of a function rule, where it's 2y, subtract 1 from the exponent, so now it's y to the 1, times the derivative of what's inside. Well, what's the derivative of y, what's inside this function? dy by dx. Okay, so one of the takeaways from this lesson, there's a few takeaways. One of them is just, you got to be careful when you're taking the derivative of y or anything else, because we're going to do it with theta and different things like that, that you include the dy by dx part, that you don't forget it. Okay, that's one of the takeaways. And then one of the other ones is what this means. Leave in implicit form. So we're going to do that momentarily. But you have to understand what that means. And then there's a couple of little quirks in some of these that people can miss. So that's the other thing that you need to really know. Okay, so what's the derivative of 25? 0. Okay, so we have taken the derivative. When it says leave an implicit form, you have to solve, but it says find dy by dx. We haven't found that. We've taken the derivative, but we haven't found dy by dx. So we have to rearrange and isolate for dy by dx. Okay, so this ends up being 2y dy by dx equals negative 2x. And then I'm going to divide by 2y. And of course, simplify the 2's. And there we go. Leave an implicit form means it's fine to have x's and y's in there. We don't have to go any further. There will be a case where we'll see not doing that. But most of the time, we leave it in implicit form. But you always have to solve for dy by dx. Nasir.
So for like polynomials, when we found a derivative, that was the function that represented the slope at that x value. So how would this represent the slope of that circle when it has two values and one x value?
Nasir, you read my mind. Why does the derivative have x and y in it? And I was going to ask, what is dy by dx? You already answered that. So what is dy by dx? What was Nasir's answer? Back in MHF, what did the derivative function do for us? It found slopes of tangents. So shouldn't this still be the slope of the tangent? But why does it have an x and a y in it? Good question. This is a circle. We already established that. Is that true? So it has a radius of 5. That's how, whoops, negative 5. That's how this works. Not that that really matters. So what if I wanted to find the slope of the tangent when x equals 2? What's wrong? Megan? You got two possible slopes? X equals 2 does not define a single location on this curve because it's not a function. And you know, we've talked about this before, probably, hopefully. That's what makes a function an important thing. That's why we talk about functions separately from non-functions. Because if you have a non-function, you can't just say when x equals 2. That's not clear where exactly you mean. That might be more than one place. And in this case, it certainly is. So you would have to say, well, when x is 2 and y is whatever y is, and in one case you'd get that, and in the other case you'd get that, right? So it makes sense in our understanding of slopes of tangents that you would have an x and a y in here in something that's not a function. If it was an explicitly stated function, you wouldn't have this generally, right? Okay, questions? It's just like sketching. I don't know if it's, again, useful to copy down, but you can if you want. Okay, so now let's try a few. So what's the derivative of 4x cubed? Well, that hasn't changed. Still just 12x squared. The derivative of negative 2y squared, negative 4y, subtract 1 from the exponent, and then dy by dx. And the derivative of 7x is? 7. Okay, now we isolate for dy by dx. And this is finished, but sometimes computer programs, textbooks, people, whatever, will do this. They'll take this negative from the bottom, bring it out front, and then apply it to the top kind of thing, right? Or multiply by negative 1 over negative 1, or however you want to think about it. And this would become 12x squared minus 7 over 4y. You don't have to do that. I'm only showing you because sometimes it happens, and it might be enough to confuse people and like, oh, why is my answer wrong? Often computer software, I find, does that. It's a little bit more simple than having extra negatives in there, that kind of thing. And that factoring out idea of a negative is an important one. It's a useful little trick. Sometimes you need it. Sometimes it's just useful. So again, it's good to see. Yep.
If you want all the answers to be positive, would you do that? If like it said in the question on test, like these answers
I will never say include as the fewest number of negative coefficients, or I've never said anything like that. So no, we wouldn't make you do that. But there could be some questions where you have to, because I mean, in this case, this isn't more simplified technically speaking. If this had a negative, if the numerator had a negative, you would cancel them to simplify. That would be required for simplify fully, but this wouldn't be required. But in some cases, doing sketches and stuff like that, it might be better. It might just make it easier. Everybody good? Okay. Uh-oh. Skipped one. There we go. Now there's something going on here. I'm going to give you a little hint. Does anybody see it? Oh, common factor. That's an interesting idea. Somebody said that this morning too. You could, but it's not going to help necessarily. We're not going to do that. Although if you want to try it later and see if it makes the question easier or harder, that'd be interesting. Zara? Ooh, what were you going to say? Same thing, and that's exactly right. Very good observation. And this is something that even though it gets pointed out, people miss it. Like, unfortunately, one or two of you might miss it on tests and stuff throughout the course. So I don't know how to make it more impressed on you or imparted on you that this is an easy thing to miss. And if you miss it on learning goals, that kind of thing, then maybe you recite it to yourself in your head 10,000 times. X, Y product rule, X, Y product rule, X, Y product rule. But people see X beside Y and they don't recognize it as product rule. So I'm going to write this down. So this is really important. Product rule. And like we did when we first started taking derivatives with the product rule, you might want to sort of write it out. So P is going to be 2x and Q is going to be y squared. So P prime is 2. Q prime is good, 2y dy by dx. Product rule. Okay, so the derivative of the first is 2. Here, I'll even do it like this, is 2 times the second, y squared, plus derivative of the second, 2y dy by dx, times the first, 2x. Product rule is done. 3, whoops, not equals, plus 3y squared dy by dx equals 0. Okay? Now we're going to isolate for dy by dx. So I'm going to move any term that doesn't have a dy by dx to the right side. Leave the other ones on the left. Whoops, 2y dy. Oh, no, actually, and I'm going to simplify this one. So this should be 4xy dy by dx. Everybody okay with that? See what I did? This middle term, 2y times 2x, I'm putting the monomials together type thing, plus 3y squared dy by dx equals negative 2y squared. What do you think we do now? Matthew? Yeah, dy by dx is a thing. It's not just notation. It's a thing that we can manipulate. So we can factor out. In fact, dy by dx can have a value. It might equal 5. And you could sub in for it. We'll see that later on. So dy by dx, 4xy plus 3y squared. What does this feel like a little bit? Anything to anybody? Huh? Okay, interesting. Simplified fully, yeah. Not what I was thinking, but fair enough. For some reason, it reminds me of those equations in the logarithms unit in MHF. Is that what you were thinking? Yeah, see? Where you got to factor, you got to move everything around, and the big long ones, right? But that's really repetitive. And then you factor out the x at the end and then divide by the big chunky part. Okay. dy by dx equals negative 2y squared over 4xy plus 3y squared. There we go. Anybody notice one other little thing we could do if we wanted to? Factor out a y, and it cancels with 1 on top, which is kind of nice. So this would end up being negative 2y over 4x plus 3y. A little bit more simple. That doesn't happen very often, honestly. But, you know, it's always a good idea to simplify fully. But with these, we're not simplifying fully in terms of fully factored. Like, we're not doing that. Those two worlds don't really cross over. Implicit differentiation with the simplified fully, because usually the implicit differentiations, they're messy things, right? And they're implicit, so how would you fully factor? Like, they don't go that way. Was there a question? Somebody have a hand up? No? Everybody's good? Okay, one more of these. You can go ahead and try it if you like. Sometimes these negatives can cause people problems. Because this is product rule again. So is your product 3x squared times y to the 4, or is your product negative 3x squared times y to the 4? Well, it could be either, actually. So what I did was negative 3x squared, and that's why I have negative 3x squared there. But I could, in a way, factor out the negative, and this would instead be 0 minus 6x y to the 4th plus 4y cubed dy by dx times 3x squared. And you can see how the negative is going to be distributed to both terms anyway. Do you see that? This term is negative because of the negative sign here. And this term's negative because they're both, right? So no matter which way you do it, it's going to work out the same, of course. But, you got to do one or the other. You can't do a mixture of both. And people would do this way and then forget the negative here. That's why it's so tough. There's so many little things that can happen. Okay, equals. What's the derivative of root 2y? Nice. Root. A lot people might just think it's just root 2. Remember, you got to take the derivative of y as well, dy by dx. So I'm going to move all the dy by dx's to one side, and I'm going to move all the other junk to the other side, and I'm going to start, factoring out and simplifying and all that stuff. Oops. Minus plus x squared y cubed. So for this one here, I multiplied the negative 3 by the 4 and got negative 12. Then when I moved it to the other side, it became positive again. Okay, then x squared and y cubed, just putting those together. I think I got everything. Yes, thank you. This part right here. Okay, is that fine? Happy with this?
Doesn't matter whether or not the square comes first. Or
Nah. Usually we write constants at the end, but that's why I did it. Good? Good? Yeah? Fine? Okay. Okay. Find the equation of the normal line. That's new. To the curve, blah, 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 blah. Now this curve is kind of interesting, actually. We're going to look at it later. This is like find the equation of the tangent line. So we're going to start it and talk about what a normal is after. But it's like a tangent line question. So if you're finding the equation of a tangent line, what would you do? Take the derivative in order to find the slope. Exactly right. So we're going to start by taking the derivative of this. I've got a y term, I've got an x term, and I've got an xy term. That's product rule in the middle. Right? So I've got 5y to the 4th dy by dx. Product rule. x squared times y. Like x squared times y is such a simple little term, but its derivative is more complex than you would expect, because this whole thing is the derivative of that, right? The derivative of the second part is just dy by dx times the first part. If we want to determine the slope, this has to be in dy by dx form, equals form, like it's got to be solved for dy by dx. This one doesn't say find dy by dx like the other ones did and leave an implicit form. Doesn't say any of that, but we have to do that anyway, right? So 5y to the fourth dy by dx plus x squared dy by dx equals 4x minus 2xy. Yes? How do you know that? Oh, you see those in physics? Ah, the normal force. Ah, very good. Good guess. I think there was a challenge question that talked about a normal this unit. Did anybody see it? Did anybody look up the definition of the normal? I don't know how easy it would be to look up. I don't know what would happen I think if you typed normal line to a curve, it would come right up. But so you're exactly right. Okay. So if this curve, interestingly, looks something like this. What happened? I just erased it. Whoops. Okay, it looks something like that. And we're finding the normal to the curve at 2, 1. This would be the tangent. The normal is a line that is perpendicular to the tangent, but through that same point. So we're going to find the slope of the tangent. How am I going to find the slope of the tangent? I've got an expression for it. Megan? But how do I find that slope? Sub in the x and the y. Right? We need both, because this thing has x and y in it. So 4 times 2 minus 2 times 2 times 1. So this looks like 8 minus 4, which is 4, over 5 plus 4, which is 9. So the slope of the tangent is 4 over 9. Whoops. 9. Normal. Perpendicular. So Megan, what is it? Negative 9 over 4. Negative reciprocal from grade 9. How do you find a perpendicular slope? Take the negative reciprocal of the slope. The actual definition is the product of the slopes equal negative 1. That's the actual definition. So if I take the product of 4 over 9 and negative 9 over 4, I get negative 1. 36, negative 36 over 36, right? That's the actual definition. Everybody okay with that? Okay, and then y minus y1 equals m x minus x1 at 2, 1 with a slope of negative 9 over 4. in standard form. Any questions?
What if this question you only have the x value?
Then you would sub it in to the original curve to find y. Which for this curve, the way it's written, I don't know how that would work. So you wouldn't be asked to do that. Yeah. Okay, we're going to do one more. So find the points at which the slope of the tangent to the given curve is 1. Now when you're doing this, if you want to bring up GeoGebra or Desmos and type these in, some of them will look pretty cool. Like they're not functions. Some of them are and some of them aren't, but they're not functions and they're interesting. Might be worthwhile taking a look at. So the first thing we're going to do, like usual, this is one of the other kinds of questions that we looked at on day 2 of this unit, is take the derivative, right? So 3y squared dy by dx equals 3. That was easy so far. dy by dx equals 3 over y squared, which is 1 over y squared. Okay? What would be our next step? Second? Okay, so I'm going to come over here and do it. So 1 equals 1 over y squared. Right. Mm-hmm. I'm going to move the y squared over first. And then I'm going to square root it, is what you mean. Very good. So y is plus minus 1. So we've got 2 answers to this. What if there was an x and a y in the derivative? You can't solve an equation with 2 unknowns. So there wouldn't be. You know what I mean? There couldn't be, unless somehow you got a linear system out of it or something like that. But we don't do that. So, okay. So I'm going to stop here. So now we're going to find x at y equals 1. And we're going to sub y into what? The original equation. Yes, right? Because we're finding the x value, which is associated with the y value that is a point on the original function. So I'm going to stop there and let you finish that. But it would look, I'm just going to write this down so that it's obvious. 1 cubed equals 3x plus 5. And you should get an x value that goes with each of those y's. And then you have your 2 points. Before I stop, I'm going to show you these 2 functions. So this was the first function, okay? And GeoGebra is really cool if you haven't used it too much. If you've used Desmos, GeoGebra is better for some of this kind of stuff because watch what you can do. So I typed in, and look, it calls it an implicit curve. I typed it in, it's equation 1 here, is example number 2 that we did today. And all I have to do is click a point where I want it, which is at 2, 1, see? And then I just go, okay, I want the tangent to that. I clicked the point, then I clicked the curve, gave me the tangent, there's the equation. Then if I want the normal, I go perpendicular, I click the point, and I click the line that I want it to be perpendicular to, and bam, it just pops right up. Right? So if you find the right tool, you just have to click around and you can make it work. Okay, it's really neat. Let me get rid of this stuff again. This is the other one. So this is the curve. I should make it a different color maybe. This is the curve. There's the 2 points. y equals 1 and y equals -1. And there's where the slope of each of them is equal to -1. Like you can see that those two slopes are parallel. So this turns out to be a function as well. But some of these implicit things are not functions.